Before starting our video, I would like to tell you one thing: we are providing this video in different languages, so there is no more language barrier for learning. Find your language in audio tracks or subtitles to watch this video in your mother tongue. If you couldn't find your language in the list, then let me know your language in the comment section and I will add it. Anyway, in this video we are going to learn how to find classes and field offsets related stuff without any scripts or tools. Only Game Guardian with a dump.cs file. So this video will have more information, so stay tuned. I know with scripts and tools this process will be easy, but you should not depend on those tools without any knowledge of how things work in the background. As a real hacker, we use them only for automating our tasks, not for skipping the learning part, so don't go down that road. After gaining knowledge, you can use those. So if you still don't like to learn the background actual process, then you can skip this video now. So that means you are not leaving and are interested in learning. Good, I will teach you. As usual, begin with the theory part. If you skip this valuable theory part, you won't understand our practical session and it may confuse you. Make sure not to skip even 1 minute. We are going to learn very valuable stuff. First, let's see what kind of info our metadata and so files contain. We already discussed this in our previous videos, so I am not going to explain again briefly to reduce video length. I list those fields here so you can see. Like we discussed previously, IT only contains metadata or info, not the actual coding or instructions. Those will be in so files, not here. I list each field and its components here so you can pause the screen and read and understand what it will have. If you do not read this, you will not understand what I am talking about when we start our hacking and why we will get particular details in a specific order. Moreover, some data is not visible or readable for external tools/scripts. It is only readable for internal function/game data. That's why we inject our code or mod tools into the games to pretend like we are also a part of the game. In our previous video, we opened the so files in hex view and looked at what is inside them. When you see this, you may realize that our practical analysis and these fields are matching. We see elf, program headers, section headers, symbol table, dynamic links, machine codes. In our first dumping video, we easily found our method/functions by adding the RVA to our so range and modifying its value to hack specific things. Because like I said previously, the code-related stuff is stored in so ranges, not in metadata. Even if it is related to the class, IT will be stored in so files because the code/logic is stored there. So in simple terms, labil2cpp so contains compiled game logic, function implementations, and memory layouts. Global metadata contains names and structures. Together, the metadata tells us what exists or what we can expect in it, and labil2cpp so tells us how it works or what the logic behind those is. Usually, when you dump Unity games with il2dumper, you will get this dump.cs file, and at the start you will see DLL lists and their ranges. Many people ignore this, but this is also useful in finding class ranges or validating those classes. Also, everyone directly searches what they want like diamonds, coins, etc. When you search, you may find more than one result, and after refining you will get your correct class and try to get remaining variables and hack those which are in the same class, which is good. But when they try to find another class, they do the process from the start again. If few classes have the same object referencing, then we can easily find more than one class at a time with that one object. Maybe I am going a little in depth, don't worry, while hacking you will understand better. Here each DLL has its range. If you scroll down, you will find classes and their contents like fields, parameters, methods. Some of them only contain fields or methods depending on the class. If you observe the starting class, it says module. Each range will have one module. You can see typedef index numbers alongside the class name, which is useful to tell which DLL has this class typedef. So all classes in this DLL range will refer to this module. That's how the game maps classes. Remember this point because in this video we will see this concept practically, so you will understand better. Instead of searching directly for what you want, look at all these classes and what they have inside them. Sometimes you may find one variable you want and think you hacked it, but if you look around, you may find more valuable things than that. Also, whatever you think is hard to find in the game, you may find it easily or you may find an indirect way to hack or trigger that hard thing. That's why I always tell you, even if you don't want anything more valuable than what you got, just look around. You will understand what more the game has or how the game works. See, we have methods of this class. You may see some tools or scripts ask you for the function address to find its class. Because, like I said before, finding function/methods code is easy since it is stored in range which is stable. If the function is not static, then it may contain a keyword is, which directly refers to its function class instance. From there, they can easily find the class. I already showed how to find methods in our first dump video, so I am not going to show again. Now you may have a doubt, can't we do the same thing with field offsets? No, we can't. Because those field offsets are not instructions or code. They are either pointers to other objects/instances or values, so they stick to the class instance. Some field offsets are static, and those will be stable. If you get those field offsets, then you are lucky you can find your instance easily next time with the fixed offset. For that, you have to find it first and then calculate the offset. For other field offsets, we can't get fixed offsets. Games only store class metadata and functions in stable places, not the values or data. Those are stored in anonymous ranges. That's why each time when you try to change a value, the address will change. If you observe, field offsets and method offsets have a huge difference. Because class instance base address plus field offset equals actual value address. Method offset is .so range plus relative virtual address offset equals method offset, which is stable. So we understand methods are stable, and class instances and fields are not stable. Then how do we find them? As we just learned, metadata contains the names of our classes as fixed offsets. With that, we can find our instances. First, let's see how it stores them. Here we have our metadata, and this metadata will always change its place, but what is inside it will always stay at a fixed offset from the metadata base address. In metadata, each thing has a separate fixed block. We already saw what those blocks are. Here we have the fixed block for all our DLL files. For example, let's take assembly sharp DLL stored at this location. Like we said before, whatever is stored in this metadata is at a fixed offset, no change. This DLL has its range, and we already saw that in our dump.cs file. If we go to that range, it will contain all its class names. I just showed a few of them, but it will contain all class names that you can see in the dump.cs according to the assembly sharp DLL range. Like I said before, we only get instances or data if they are accessible to external tools. Sometimes you may get instance bases but not the expected data at certain offsets. This may be because the instance is not activated yet, so it refers to garbage values, or the instance is already dead, or it leads to a dummy/duplicate instance for external tools. In this scenario, we have to inject our script/code or tool into the game internally. Now we are going to do the regular method, which most people use. First, we find any field address or value, then subtract the field value from its address to get the base address. You can see here follow the green arrow. Here we face one problem. Like I said before, if you search one keyword, we may get a lot of results in the dump.cs file. So each result will have a field offset. We have to note all of them and try one by one. If you get a purple colored address, then go to that class in dump.cs and try to apply another field to that instance to verify it. Then you will get one correct address. That is your class instance. Let's start the game in practice mode. First, look around and try to find something to hack. Here, I am getting a new option to pick it, so let's try to find anything we have in our dump.cs file according to this vase. If I don't find anything, then I will look for something else which we can get in our file. Let's search for vase, check the results, and pick which one is suitable for what we are looking for. See, we got something interesting. We have GameObject, transform, and a bool value also. Always look for bool type field offsets because those are easy to find the classes, since bool values only store either 0 or 1. If we scroll up, we can see it's a class. We got the inventory controller class name, and it looks like all of these are related to inventory. So I think we got the best class for starting the hack, but we are not sure yet. We have to look at other results as well. See, under vase we have vase2, and that is also a bool value. Great. That means we have 2 vases in this game. Let's find more if we have any. See, we landed on another place where it is also pointing to the GameObject and transform of vase and vase2. But here we don't have bool values, so that means this class is not useful for now according to the vase hack. I am not saying this is not useful entirely, I am just saying according to hacking the vase. If you look in this class, we may find valuable stuff also. Anyway, let's look at this class name. See, we have pickup. This is related to our vase because we are currently trying to pick it. But still, we don't have a bool option in this, so we can't hack directly. We can try to hack this vase indirectly with the help of the inventory controller class, because it has a bool type value for the vase. Like I said before, as a hacker we always analyze to get more information, so that if we can't directly hack one thing, we may find another or indirect way to hack it. Don't think I am repeating this point for no reason. I get a lot of comments where people follow only one method and then tell me they can't hack something. I always say, look for another way. But they don't even try. Anyway, don't make that mistake. So even though it is related to our action, since we don't have a bool, I will skip it. Let's search more. I think it will take time, so I will check and come back to you. Okay guys, I searched everything and didn't find anything more valuable than this class, so I took its offset for our hack. Let's take its class name and field offsets. Since we already know it's not a static field, it must be stored in the anonymous range. If you see the word static before your field name, then you are lucky. If you find the field, look at the static/stable range where it is stored and calculate the offset from the starting point of that range. Then next time you can directly go there with the offset. Now I am selecting the anonymous range. It's not necessary, you can leave it, but I know it won't be stored in fixed ranges, so to reduce results I filter only the anonymous range. Let's find this vase. Since it is a bool type, just refine 0 and 1. Currently, I don't have the vase, so first we need to find value 0. Now I have the vase, so I have to refine for 1. Keep doing this process until you get a few values. See, after refining we have 19 results. You can still refine more, but I will show you one technique. I am not saying this will always work, I will explain why. Before that, I will show you one more way. Sometimes we get duplicate values along with the original value. No matter how many times you refine, those addresses will still remain in the results, so you will be confused about which one is correct. If you try to change those values one by one, you will find the original value no problem. But sometimes, if you change certain values, they may be referenced or checked by something, and your game may crash. So to prevent that, you have to do one thing. See this. Now select an address or result. Let's check the field offset. Now we don't know which vase we have, so we have to check both. We can find the correct one by subtracting its field offset from the address. Now I am expecting an instance, which is usually a pointer. See, this is a normal one, that means it's not the instance. If you don't know how a pointer looks, let me show you. See, this is how we recognize a pointer by its color. For this, make sure you select the hex value option. If one offset doesn't work, try another. If you get a pointer, then go to where that field is stored, take that class, and check another field. If every offset works fine, then that is your address. But like I said, I will show you one technique. We already know the offset is 158. Sometimes instance addresses end with zeros. So if the address ending matches our offset, then it might be our address with about 95% probability. So let's check our results to see if any address ends with 158. Wow, see, we have one address. First, let's confirm this by changing its value to 1. See, currently we don't have any vase, but we changed the value to manipulate the game so it thinks we have that vase. We didn't actually transform the vase into our hand, we just hacked the code. You can also modify object locations to teleport them into your hand, but that's a different topic. Anyway, now let's pick the vase and see what happens. Wow, did you see what just happened? Until now we had one vase, but now we have two vases. Why? Because we manipulated the game to think we already had a vase, but we didn't modify the visual or 3D object. That's why we didn't see it in our hand. When we picked the object, the game dropped the existing vase and picked the new one. That's why we now have two vases. Now it's confirmed we have one valid address. Now the big question is, are we actually in the correct class, or did we miss something and assume we are correct while actually being wrong? Let's confirm it. Before that, I want to remove the remaining results. I am naming it vase 1, but I am not sure yet. If this offset doesn't give me a pointer, then I will try the second vase offset. If that gives the correct class instance, I will rename it to vase 2. Let's test one more time. See, now we got two duplicate vases here. Now let's save it and find its class instance by subtracting its offset from its address. Wow, it looks like a pointer. But remember, every pointer is not necessarily a class instance. To confirm it, we have to check other offsets in the class. There is another method also, and I will show it in a few minutes. For now, I am assuming this is the correct class and naming it to avoid confusion with other addresses. Now try to add another offset and check it. See, this is also a bool address. Still, we need to verify. If something new happens, then we can confirm this is another field and that we have the correct class instance. Now I am changing the value. Let's see the magic. Wow guys, we got another vase. That means we are in the right class, and with this we can get a lot of things. How cool is that? Let's see what more we can get from this class, because it has a lot of bool values perfect for practice. See, we have something I don't understand what it is. Let's check it. we got a piece of painting. Did you see this, guys? This is what I said at the beginning, not everything is named the way you expect. This is the best example. If you wanted this, how would you search? Maybe painting, granny painting, or piece of painting, because that's what it shows when we aim at it. But internally, it is saved as something like have TB1, which might mean have table painting piece 1. Because we have to assemble these pieces on the table. Anyone who played this game might understand. Even I don't know much about this game, I just watched a few reels years ago. Anyway, that's why you should check the full dump.cs file to find interesting things. Even if you don't find the exact word you are looking for, try everything, one of them will match your value. Did you see this cutting plier? It is also stored with an arbitrary name. Normally we would search cutting plier, but we wouldn't expect this name, right? Luckily, I accidentally selected a perfect game for this hacking demonstration. Even I didn't expect it to be such a good example. See, here we have a hammer, so that one is understandable. Let's try it. See, we got a hammer. Here we have a lot of values, guys. Try all of them and check them. These values are your homework. You have to find these values directly, like I did with the vase. Practice finding them in practice mode. Here we also have methods, but I am not going to show those, because in our first dump video I already showed how to find and change those values, and I explained the theory there. In this video, we are focusing only on classes and field offsets. Now this time, we learned another method of finding the class name. Just follow the green arrow marks. First, we have to find the class name, which is located in the DLL that is in the metadata range. From there, if we pointer scan that name, we will land on the class structure. We already learned about this in our theory part. The class structure will contain those class names and details. When we subtract 10 from the structure address, we will land on the class base address. You may have a doubt, Why didn't we land directly on the base address of the class instead of landing on the structure? Because the class base address always points to this DLL module. We already saw this in our theory part. If you skip the theory part, go and watch it, otherwise, you will not understand. So not only this class, every class base address will point to its DLL module. Each DLL has its own module, and every class in that DLL points to that module. Now, if you search for pointers to this class, you will get a lot of results. You may wonder why we get so many results instead of only our class instance. In games or any project, classes are accessible by other contents or functions in the program, so we get many results. Even the module address is accessed by many things. In those addresses, we may get duplicate class instances, dead instances, or some other functions or unrelated data. After you find your instance, then as usual, you go to the value you want using its field offset. Now let's see how to do it practically. First, let's delete these addresses. Take the class name and search for it by selecting the text UTF-8 option. Or select this option. Now paste it. In this method, we are searching for the class name, and we all know class names are stored in the metadata range. Nowadays, metadata is sometimes stored in another range. You can select only the range, but for good practice, I keep the remaining ranges as well. Now we got a few results. Let's refine the results. We want only the starting letter of our class name, so I refine it using the starting letter. Before that, carefully check if we have any duplicate starting letters in the class names, because you may get those addresses as well. In my case, I don't have duplicates for my starting letter, and it is also in capital form. If in your case your starting letter appears in multiple class names, you have to select only the correct one. Don't worry, I will show that example in a few minutes. Now let's refine it. Here I got a few addresses, and I think you already know what we want. Yes, we need to delete the anonymous range addresses. Those keep changing, and we don't want them. Sometimes, even in this range, they may not refer to metadata, they could belong to other ranges as well. But don't worry, one of them will point to the metadata range. For that, you must select the correct range from your range list. I already showed how to check which range an address belongs to in our previous videos, so I am not going to repeat that now. I have all metadata ranges, so I save all the addresses to the Save tab. Let's do a pointer scan for each one. See, we got pointers for this address, but we are not sure yet. We have to check the others as well. If they also have pointers, we need to apply the same process to them. Luckily, we have only one address that has pointers. Now here we have two addresses, one in the anonymous range and another in the range. Now I will tell you a small trick. The module is always stored in the anonymous range, so you can directly go for that. Another important point is that DLL and class names are stable because they are stored in the metadata range. The remaining things, module, class, class structure, class instance, and fields, are usually stored in anonymous ranges in modern games. If you don't believe me, Then let me prove it. First, let's save these two values. Now, as we discussed previously and also learned from the chat, the class name takes us to the class struct. So we assume one of these is the class struct. To confirm the right one, let's pick one address and subtract 10 from its address. We already know the class struct starts at base address plus offset 10. See, it does not look like a pointer. Let's confirm it. See, it is confirmed that it is not a pointer. See, this one looks like it is pointing to the module because we already know a class always points to its DLL range module. See, it is confirmed. You may have a doubt like it is a pointer, we can understand by looking at the purple color hex value, but how did you know it is referring to the module? Good question. I just saw that string like X, dollar symbol, P. But it looks like it does not make sense to us. I agree with that. Even not every module has the same letters. Each module will represent or show different letters. But after hacking a few games, you will understand whether it is a module or not due to experience. Also, I will show how to confirm whether this pointer is pointing to the module or not in a few minutes, so don't worry. By the end of this video, every piece of information will align with each other and give you a perfect picture or blueprint in your brain for finding classes and fields. Now I am naming it with its class name. I will name the remaining also accordingly so we don't have confusion. We already got our class instance previously, but still I will show the way to find it again using this method. Before that, I will show the proof that the class names are stored in metadata. And I am not telling you that class names are only stored in metadata. You already saw that when we look for a class name, we get some results stored in anonymous ranges as well. And those anonymous range addresses will not be useful for us, so don't waste time on them. We took the address where our class name is stored in the metadata range. That is why through it we are reaching our instance. We are just one step ahead. Let's see where our class name starting address is stored. I already said previously it is in the metadata range. And we already know how to check it, so I won't show it. But some people skip those parts in previous videos and come to ask again, so I will show you how to check again. Copy the address. Paste it here. Click on the drop-down button. See, this address is in the metadata range. I hope you understand how to confirm the range. Don't ask me again and again. I will not reply to those comments who ask something I already showed practically. You can clearly see here the metadata magic bytes in reverse hex format which we discussed in our previous video. Now let's find our class instance with the help of the class base address by pointer search. See, we got 5017 results. We need to find the correct one in these values by applying field offsets and checking those values by changing them and confirming it. Because a few classes at the same offsets may have the same data type. For example, in this scenario, we are looking for bool. So don't think when you find a bool value at the same offset by adding it to the wrong address. Doing this for each and every address manually will take a lot of time. That is why some of you may drop at this point. But don't worry, I will show you a trick which reduces that time. And even sometimes, if you are lucky, you will get your address more quickly. Now make sure the show range is higher than your results so you can contain all results and select all at a time. Before going to the next step, let me show one thing which will reduce 1 or 2 steps in finding the class instance. If you observe here, every range is located in the anonymous range. But here we have a CD range where the address is a 32-bit range and referring or pointing to our class base address. And since it is stored in the CD range, it will be stable. Not every class will get this stable address pointer, but if you get it, then you are lucky. Also, it does not mean it must be a CD range. It might be any stable address or range. If I copy the address and look at its range, see, we land in the libil2cpp.so range. So if you take the starting address of the lib range and find the offset from the starting lib range to the CD address which we got now, which is pointing to our class base address. Then from next time, you will directly go to the lib base address by clicking this XA range. Select the range based on the 32-bit or 64-bit range which you got. Add the offset and go there. Then reach the class pointer. Then find pointers for that and get the instance. If you are confused, don't worry. We will do it practically in a few minutes. First focus on this method. Since we all know instance always stores in the anonymous range nowadays, so you can only select the anonymous range in the address list. But since I got all in the anonymous range, filtering is not useful for me. Before showing the long method, I want to tell you one quick technique. If you have any info like the specific class instance address ends with specific numbers, then you can filter those to refine faster. For example, I know my class instance address always ends with 000. Don't worry, I will show the actual process as well, just wait. You may have a doubt, how did I know? See, I saw it here. Remember, even if the game uses ASLR, each run the address will have the same ending numbers. There is no change in the last numbers in most games. If the game is updated and the developers patch it, then you may see different addresses. Now go to this address search option. I already showed how to use it in our Game Guardian Tools explanation video and a few videos before also. If you don't know how to use it, then watch those videos. Now I am searching like this. The question mark symbol tells Game Guardian that no matter whatever the address starts with, it must end with the specific numbers which I gave. In our scenario, it is 000. So whatever contains 000 at the end of its address will be visible, and the remaining will be removed from the results tab. See, from 5017 results, we filtered to 15 results in just a second. How cool is that? You can use that address searching option in these scenarios advancedly. If you don't know, then watch our videos where I taught those techniques. You can see our address at the end. You may have doubt how I can say that without watching the address. It is simple. Whenever we change an address value or name the address, it will have the previous value in curly brackets. So I already named it, and it shows the value in brackets. Now, like I said, even though we filtered drastically in a single step, we still need to check our address. Don't think we already have it, so why we are doing this? I am just showing this in case you see your last numbers of your address. Even though the address changes every run, the last numbers won't change. But it does not mean the game only has one address with those last numbers. Here we have the same numbers for 15 addresses. So we have to find it manually if you don't already have your address. So just watch the process. First, you have to open the offset calculator for that address and take any field offset. Bool is the best option for us. Add the offset here. See, we are expecting either 0 or 1, but it is showing some other value in byte format. So this is not what we are looking for. And sometimes, like I said before, a few addresses have the same data type at the same offset. Then we have to look for other offsets to filter the confusion and get the correct address. Sometimes you may see either 0 or 1. Even then, don't blindly believe it is the right answer. Just verify whether you triggered the action which that offset represents. I mean, I am looking for the player having the VAS offset address. Currently, I don't have VAS, so the value must be 0. But if I add the offset to the address and it shows 1, don't think that I am looking for bool and it only shows 0 or 1, and I got 1, so this is the right answer. No, don't think that way. Just make sure the remaining factors also match. Like I said, don't blindly trust it. You can change the value and see if any changes happen as you expect in the game, and only then confirm it. Let's do the same process for all. See, this is not our address. And it also has a bool value and shows 0. Which is matching our scenario. I am looking for VAS, and I am not holding VAS, so the value must be 0. See, now we have only 2 values. Now we can change those values and check which one gives the changes we expect in the game. Now to prove my statement that different instances or addresses may have the same data types at the same offsets, I will add my field offsets to this and check it. I only add bool field offsets which only give 0 or 1. Observe the values. See, everything is as we expect. But we can't believe it yet because I am not changing values. I am just proving it by adding offsets and checking those values. Let's try more. See, this time we get a different value. But we added a bool field offset, so it must be 0 or 1 based on the action. But it has a different value. So that means this is not what we are looking for. This is the right one. Let's delete it. If you open it, we have our saved name here like I said before. Now, if you don't have any clue about the last numbers of your address, then follow this method. Like I said before, increase the show range so it will be easy to select all results at a time and save them. Go to the Save tab and select all and remove if you have any saved addresses in the Save tab. Now select one field offset to check on these addresses. Click this Change Offset and Data Type of the Address option. Paste your offset here and select the data type you want the value of the address in. In this case, mine is bool type, so I am selecting bool data type. See, all addresses changed at a time and data types also. If you want to do this in the Search tab, you have to do it one by one, which takes more time. Now let's push these addresses to the Search tab by clicking the Select Address Replace as Results option. Now refine the values. See, it drastically changed from 4000 to 95 results. Good, right. Now let's do this process again to refine more. Before that, I have to remove these already selected addresses to get rid of confusion. Now again deselect the saved addresses if you have any in the Save tab before. Let me go back to the previous address by subtracting the current offset from its address. See, we get back to its previous addresses. Now let's select another offset and transform them to the Search tab. I filtered again and now we got 36 results. If you observe here, at the end we have one address showing like it was already modified or named before. Since we are pretending like we never knew this value before, forget that hint. Focus on its address. The last numbers are matching our offset value, which is 170. So we can simply change its value, and if you find any changes in the game as expected, then that means we are at the correct address. So no more searching results. But still, I want to refine more and show how a beginner does things and learns the process. In refining, we have a few options like how to search and advanced refine techniques. I already explained these kinds of things before, so you can use those as well. Since we are expecting 0 or 1 value, we can use it like this. If you don't have time to watch videos and explanations, some features have this icon on them. When you click on those, you will get some examples, so you will understand. Now we do this again. Go back to its original address. See, this time I am trying another offset. Now we have 19 addresses. Looks like this time more addresses have the same type at the same offset. So in this case, if you try refining, you will only reduce a few addresses. So try another offset. This time I just got one different address. So try another one. Keep repeating the process. Now we are getting the same results. So our only option now is to modify the addresses and check the right one. So we have all wrong addresses, and the last one is the correct one. Let's see this as well, even though we know it is correct. See, it worked. Let's go back to its original address and save it. Let's name it. We can find the class name starting address with a fixed offset, like we already got the class name starting letter address for next time use. Just copy the address of it. I am taking note of it, but it won't be useful because it will change next time. We need to note the offset only. But just for practice purpose, I am showing this. Paste it here and click on the drop-down button to see its range. See, we are in the metadata range. Select that range, and it will give you the starting address of the metadata. Copy it and click on Go to Address. Now save the address and name it metadata. Now we need to find the offset. See, we got the offset. So next time we can find metadata starting address and add offset. Then you will go to that class name address directly. Finding metadata is easier than finding class names directly. I already showed the process of finding metadata, but I will show again. Make sure you are in 0 range. If you don't find metadata in this range for your game, then try other ranges as well. Select the starting address and paste the offset here. See, we landed at the exact location. From here, you know the process of finding the class, right? Now we learn another method which I told you before. That I will show a way to find your class address from a stable range or stable address if the class has a stable pointer. Here, only follow the green arrows. We have a stable range, and it can be any stable range. From there, we go to the stable pointer which points to our class with the help of a fixed offset, which we exactly did from metadata to class name address. Then it will point to our class. From there, we will get our class instance. Then you can go to whichever value you want in the class. This method is also used for simplifying searching for a class after you get your class address. Just like we did in metadata and class name, but this time it directly goes to the class address. So we just need one step to reach our class instance. We have our class address here. Now let's do pointer search again. Make sure you have selected the stable ranges. If you are not sure which to select, then select all ranges or use the default selection by resetting it. Now copy the stable pointer. Paste it here. See, we are landing on the lib range of a 32-bit range. Now select and copy the starting address of the lib. You can select it like this as well. Let's go there. See, we have our elf. And those who watched our previous video will know why we see this here. Let me name it. Now save this as well. Let's find the offset. Note it. Next time you can come here and select XA range or any range you got previously. Pick the range and add your offset and go there. See, we got our class directly. Simple, right? We reduced most of the searching part. And this only works if you get any stable pointer for your class. You may think if we have any stable pointer for our class instance, then it will be easy for us. But mostly we can't get like that. Developers don't design like that. But if you find anything like that for your game, then you are lucky. Enjoy. Now let's see another method. This time we directly focus on particular DLL related hacks. Follow the green arrow path. In this method, we search for the DLL name and only look in a range like we did for class name. Then we pointer scan for that address. Then we directly land on the module address. Here we don't need to subtract 10. When you do pointer scan, then every class in the DLL will point to this module. And other objects which need access to this module will also point to it. Also, any dead object or some other game data may refer to this module. From the module, you have to find your class address. Then you can find your class instance. You already know how to find class instance from class address. In the same way, you need to find class from the module. But when you do pointer search to module, you will get a few addresses. Then you have to add 10 offset to each one by the method I showed previously. Then you have to go where those addresses are pointing manually to find the class name. We already did this process, right? So this is your work. And it will show how much you understand. So I leave this method for you. I just gave instructions. And we already did this method in previous methods. So if you skipped any method, go and watch and understand, then apply here. Even other methods are easier than this. But you have to learn every method. Then only you can build good knowledge on this. All the best. This is our class. Now if we go to where it points to, then we get the module address. Let's name it our module. If you go where it points to, then you will land on the starting letters of your module or class DLL name. If you don't see these letters, then you need to select the string reference in Format View option at the top right side. Let's save this. See, now I did it in reverse, which we saw in our chart. You have to do it from the starting point like I explained before. Now let's find another class with the same method. I am taking this class. See, here we have our starting letter twice in our class. This is what I said in our second method. This is a good example to explain. Let me show you. Now let's refine it with starting letter. Since we have two letters in the class, we will get both values. But we need only the starting one. So let's select the second value so we can delete them easily. Now we have all second values which we don't need. And I already told you one important thing. If you observe here, I can delete a few more options blindly. What are those? If you say anonymous range also, then yes, you are right. We need first addresses, but if they are in anonymous range, we don't need them. Even if they have the first letter. Because useful first letters are only in O range. Now we have only 3 valid O range addresses. Let's save these. Let's do pointer search. See, we get pointers. But what I told you before, even if you find pointers for one address, don't blindly delete others before checking them as well. Because sometimes we may get pointers for remaining also. But I already know it is the right one, so I am naming it. Let's check remaining. See, we don't have any pointers for those. Now tell me which one is our class struct by looking at the memory ranges. Because I already told you before where you have to check. If you say anonymous range, then good. You are on the right track and understand well. Let's subtract 10 from it. See, we got our class address. See, this points to the address which is our module address. See, same address. It proves that same DLL classes will point to the module of that DLL. I think you understand that module address is not only for previous class. It is for all classes in the same DLL. Another DLL class will refer or point to its own DLL module address, not this one. I hope you understand. And again I will show you what happens if we do the same process to the orange. See, we don't get any pointer. So it is not valid. So we have our inside car button class address. Now we need to find its class instance. But this time we will try another method to find it. But before that, let's search for pointers to module address. And let's see if our class address is in the list or not. See, we have both our class addresses in the results. 757 addresses. So if you find classes from module or DLL, you will need to check all addresses. And you will mostly get all classes which are readable or accessible for other tools here. If you are lucky for your game, you will get all classes in that DLL at a time. But it will take time, so I won't show it right now. Let's see another method now. In this method, if you have one game object. Object means an instance. And don't think it is a class instance. It is a game instance of a specific thing. So class instance and game instance are different. So if different classes have pointers to the same object, we can get all those classes with this one single game object. Even those classes may be stored in different DLL ranges. As you can see in this chart. Different DLL classes pointing to the same game object. Since we already have inventory controller class instance, let's check if this class and inside car button class have any same game objects. Here let me take starting object and paste it here. If you see, this class also has the same object. But if you observe the offset, it doesn't matter. What matters is the object name must match exactly. Here they look similar, but one has a capital letter and another has a small letter. So in coding, both are treated as different objects, not the same. So with this, we can't find the inside car button class. If you don't believe me, you can try it yourself. But I am not going to waste your time. So let's try to find if we have any same objects. See, we have a game object which is contained inside the car button class also. See here also the field offsets are different, but no problem. If some classes have the same object at the same offset, then it will be more easy to refine all at once. Now let's see how to find this class with this object. First let me go to the object pointer. Now let's go to the object location. We got it, and let's try to do a pointer scan. We got 12 pointers to this object. If you observe here, we got our object pointer in the inventory controller class, so we don't need it in this list since we already saved it, so I am going to delete it. Now we have 11 addresses. In these 11 addresses we have other classes as well, but still we only need one class, so I will focus on that only. Select only those 11 results. Apply that offset by subtracting from its address, because what we get here are not directly instances, those are pointers of other classes or other things. See, we got some non-pointers, which means those addresses are not useful. Let me delete those. Let me refine more by checking another offset also. Let's try this bool value. See, we got some non-bool values. Let me delete those. Change back remaining addresses to their base address. Move these addresses to the search tab. Here I already found some classes, but still I will show how to check and confirm. Let's go to the pointer which the first address points to. See, it landed on its class address. Now to check the class name, you already know where to go, right? Let's add offset 10 to go to its struct. Now let's go to where it points to. See, we land inside the car button class name starting letter. Let's name it. Now let's see another address. You know the process, right? See, it is showing something like disabled game object. Let's search this class name in our file. See, we got that class. Check the remaining also. See, the remaining are some random stuff, so I am deleting those. Like this, you can find more classes with one game object if that object is contained in more classes. I hope you understand all methods properly. If you didn't understand yet, then let me show another option. Now let's take this game object. If I search it, see, a lot of classes have the same object at the same offset, so with this one object we can expect a lot of classes. Like we discussed, if other classes in other DLLs have the same object, then we can get those as well irrespective of DLL range. See, here we have the same offset, not exact match, so we can't get this object with our object. Anyway, let's find remaining. Let me delete a few of these addresses so we can get more space. I already have the granny object here, which I got from the inventory controller class instance. Let's do pointer search. Wow, I got 220 results. Like I said before, we not only get class instances, we will get other things of the game which access this object, so we have to search all one by one. First, I will save all to the Save tab. Since all these addresses are stored at offset 20 like we saw previously, simply subtract 20 from each address. See, a few of those are not pointers, so let's delete those. I think there are a few more, so let's move all to search results first, then I will delete those simply. Now I have 201 results. We already checked how to search the class name and DLL range, so I think I won't explain again. Go to its class address. Now let's go to struct. Oh, something does not look familiar. Now let's go where it points to. Oh, it's not landing on the class name, instead this is pointing to a class instance, so it is a pointer for another class instance. Let's see which class it is. Let's find its class. I think it is not our current DLL. Let's confirm it by going to its module location. This time the module looks different from our current DLL module. Let's see where it lands. See, we landed in Unity Engine Core module DLL. Let's go back to its class base address. Now let's go to struct. Now let's see its class name. See, it says it is base invocable call. Let's find this class name in our file. See here our class. You can see it doesn't have any field offset, still we got it because whatever we got is not actually a class, it is just some other data, and our calculations accidentally landed on this class due to these addresses stored around. So if we try it in another run, then we may get another range or some different values. Let's see the next result. It shows garden trigger. See, we found the class. Now try the next address. It is Granny Stand Car Trigger class. See, found the class here. Like this we have to check all other addresses also, so you can do it. I hope you understand now. Now bonus offsets part. Here I didn't spend a lot of time on this game, but still these offsets are more than enough, including our inventory controller class. Take a screenshot of these offsets and try to hack, and remember one thing, these offsets only work for the current version. If you watch this video in the future, then these class names may be patched or changed. I will show a few of my favorite offsets now, and I am not explaining everything in depth now because we already learned every method which I used. So if you directly jump to this part and don't understand, then watch all the previous methods to understand. Let me restart the game. This time let's play easy mode instead of practice so we can hack Granny. Let me delete all of these. I already took the class name, so let's search. Let's take only our range. We got our correct class name starting address. I am going to do a pointer search. Let's add it to our Save tab. It doesn't have a pointer. If you observe clearly, we already know our module of assembly sharp.dll, and this class is also in the same DLL, so it is pointing to that module. You can see clearly here. So let's simply delete the remaining, but in your case, if you are not sure which module the DLL has, then you already know how to find your correct class, so follow the process and find your class. I will do a pointer scan. See, we have our CD range, which is a stable range for this class, which is useful for next time. We got a lot of results, so let's take one offset and test it. Now let's try another offset and keep doing it until we find the right one. Now I change the offset. I already know the speed of Granny, so I refine it here. Let's change one of these. Oh no, that one is not correct. See, Granny still did not come yet, that means we got our address. We just set walk speed to 0, so Granny can't walk now, but Granny follow speed is not changed yet, so if Granny sees us, she will follow us. This is our granny follow speed. See, she is following us. Let's set this also to 0. See, we make sounds, still she is not coming. See, she is not moving even if I drop or make sounds. But we can't go into her range. If we do, she will hit us. We can manipulate it with a few things like set C range to 0 or player dead or player escape or when the game type of values set to 0. Let's change the walk speed so she can walk, but when she sees us and tries to follow, then she can't move due to follow speed set to 0. See, she can't move. And I want to show something, some offsets won't change, they come back to their previous value due to some other things also accessing and rewriting it. Those who watched our videos from the start will know why it happens and how to fix it. So if you don't know, then you have to watch those videos. See, it changed back to normal. Now we froze her. Now let's hack the C range in this class. We got our C range. We got our class instance as well. We set it to 0 so she can't see us. Let's find where she spawns. See, now we can go close to her, she can't see or hit us. You may think she is not moving, so maybe that is the reason she can't hit us. No, you are wrong. Let me change the speeds to normal. See, she is moving but can't see me and can't hit me. This is how you can find classes and offsets for games, and I hope you enjoyed the video. In our next video we will see how to use these offsets in our script and menu mods. Keep learning. See you in the next video.